I'm Kevin Boyd, the CIO at the University of Chicago. I'm very pleased to welcome Sanjay Krishnan, who's a faculty member at the University of Chicago. And today we're going to be talking about an introduction to generative AI. So Sanjay, if I can ask you, maybe if you could just, for us, briefly introduce generative AI and tell us a little bit about why this has become such a significant part of the technology landscape and conversation today.
Absolutely, Kevin. Thank you for having me. So generative AI is a catch-all term for using statistical techniques to generate a significant amount of multimedia content. So whether that content be language, images, video, we're seeing this new technology on the horizon that not only can analyze data, but can also potentially generate new types of data based on simple human inputs.
Okay. So the concept of AI has been around for a while. How does generative AI differ from the AI that we've been talking about for a while?
Good. So I think at its heart, generative AI, as we're talking about it today, is based on a core piece of technology called statistical machine learning. And what statistical machine learning does is it looks at large amounts of data and tries to identify patterns in that large amount of data. And what we have really found over the last few years is that there are interesting scaling effects with data. As you collect larger and larger data sets, you can model richer and richer patterns, the same way that a literature scholar sees motifs that cut across multiple books. These models see common themes in images and videos across the scale of the internet. And you pick up enough of these motifs and enough of these themes, you can start being able to generate very convincing content on the other side of it.
So that's really interesting. And I think, like, when we talk about generative AI, for some of the people that I talk with, they feel like this just came out of nowhere. Like, all of a sudden, all we could talk about was ChatGPT and Bard and some of these tools. But I think you and I know that that's not really the case. Can you talk a little bit about the evolution of generative AI?
Absolutely. And I really think that the real question we should be asking is why here and why now? And with generative AI, it's a confluence of really three factors that were already on the horizon. First, the internet has created a vast corpus of human-created data that is largely publicly accessible. So first, we have an extremely large amount of data of human content, of human-generated content, and richly annotated with website titles and URLs and links and so on. So we not only have data, we have a lot of rich annotations and metadata about this data. That's kind of part one. Part two is that we've seen technologically over the last 2 decades the rise of something called deep neural networks. And this modeling technology has allowed us to find richer and richer patterns in data. And the last thing is the rise of cloud computing has allowed us to not only think about these models and think about them philosophically, but actually train them practically. So these three things, cloud computing, internet scale data, and deep neural networks, is really, the natural next step is convincing multimedia content synthesis. And that's been where AI has been going for the last 10 years. And I think it's been realized because a lot of different pieces have actually come together.
So from your perspective, what would you say is it that makes AI particularly important? Is it really the pivotal thing for this technological era?
Good. So I think that the best way to think about what makes this new brand of AI transformative is really the changes to the human-computer interface that I think are on the horizon. When we think about computers, when I think about computers when I was a kid, it took a substantial amount of expertise to use even a simple program. I think that when we start seeing software that has natural language understanding, it can understand English prompts that you're giving it, or it can understand the visual world, or it can understand videos. Usually computers just thought of this type of data as just bytes on disk. Now it can really understand the what and the why of that data more than we could ever do before. Now, there are always going to be pros and cons to everything, and like sometimes these computers are going to get things wrong, but I think I see that as the transformative piece here, right? The way that humans interact with computers before was programmatic. Now it might be much more conversational in the way that we are talking today, just because we have given these computers new understanding of language.
And I think for many of us who are using these tools, it is fascinating how we can chat with them, interact with them, ask them questions, ask them to do something for us, and it seems like they respond, they answer, they're able to understand our question and respond in a way similar to what a human being might do. So The way you're describing that sounds like a pretty important milestone or landmark in the evolution of computers. As you think about the advancements of AI and generative AI, are there other things that you see as major milestones on the path, either things that we've seen in the last few years or things that you see coming?
Absolutely, and I think that every time that there's been a shift in computing, there's been a corresponding shift in society, right? Like when the World Wide Web came out, I don't think anyone could have projected the world we would have been in 2 decades later because of the internet, because of social media. And all of those were natural consequences of the technology in hindsight, right? When you create this decentralized marketplace of information, suddenly all these new products, all these new services, economies, impact on government all happens. I think AI is in that 1990s World Wide Web stage today, right? That we're seeing a change in the way that humans interact with computers, much in the same way the internet was a change, the World Wide Web was a change in the way that humans are going to interact with computers. The economic, social, technological impacts are limitless. And I'll give you an example from, oddly enough, our own field of computer science. We're seeing that there's a generational shift with the next generation of programmers on how they program code. They're increasingly using these tools to help them, right? And that's one example, but I'm sure in every single industry, we're going to see a similar kind of story. A story where somebody is using AI in a way that we actually didn't expect, but is great. It's like it showcases the technology.
So as someone who was in the industry with the introduction of the World Wide Web and now being here for this, they do feel similar, but it also feels like this is happening at a much faster pace. Do you think that's true, or is that just a perception?
I think it's one of those things that is hard to say. I think that I think seeing how the next so many years pan out is going to be really interesting, because I think that there are differences, right? I think that when one example that I always give is that while the World Wide Web was this revolutionary idea of a decentralized set of servers all hosting content, that content was all public, there's kind of a different market impulse on the generative AI side, a little bit more of consolidation, where there are a few major players that seem to be consolidating data rather than diffusing it around the world, right? And seeing how that plays out will be really interesting, right? And I don't think anybody actually has a clear answer of how this world is going to play out. But I think that it's an exciting time to be a computer scientist. We're seeing a lot of renewed interest in our field, as well as I think people from areas that didn't imagine that they would ever use AI, seeing applications of it now.
So let's continue with that. It seems like generative AI has application across many different fields.
Yeah.
Can you highlight a few areas where you think it's going to really be transformative?
Yeah. I think that there are a lot of fields where I think, again, I go back to my thought process on how I think about generative AI. The key thing that it has changed is a human-computer interface. There are a lot of fields where a creative has to spend a substantial amount of work convincing a computer on how to act on their creation, right? Whether it's a designer figuring out exactly how to get Photoshop to position something just in the way that they want it to be positioned, or whether it's a website programmer figuring out, oh man, this link is not the right color, I have no idea why. I find that is going to be where the first wins of generative AI happen. It's going to allow people who are creative to work with computers better. Now, there is, like with every piece of technology, I think that there would be a bunch of people who would argue with that, saying that ultimately these generative AI tools are trained on the products of creatives. And that is absolutely true, and that is going to be something that as society we're going to have to sort out. But I think that is where I see the first place of impact, that changing the human-computer interface. Where there was before a struggle with getting a computer to do exactly what you wanted to do, this is where these tools are going to help. And just as we see programmers already using it to write routine pieces of code or even debug complex pieces of code that they just can't see what the bug is, I think that that's going to be the next step. It's going to hit every single one of these applications. And the way I think about generative AI, changing the human-computer interface.
So as someone who has tried to make some of these image editing tools do what I wanted to do, that example really resonates with me, because it's amazing how much easier some of these new tools like DALL-E and others, Midjourney and the like, I can tell it in fairly English language. You know, I want to see a dog in a spacesuit on the moon, and I get that. Like that makes it possible for someone like me, who's not a graphic designer, to fairly quickly and easily do some of these tasks. But you highlighted that potentially there are intellectual property concerns of doing some of those things, as you know, much of this has been trained on other people's work. I'm sure that there are challenges with generative AI. Can you talk a little bit about those? And as a computer scientist, what are some of the potential ways that you see to solve some of the challenges?
Absolutely, and I think that the ghosts of the early days of the World Wide Web have never gone away, right? The same way the internet raised complicated questions about ownership and licensing and now misinformation, we have exactly those same concerns with generative AI, right? The question is, who owns the data that goes into these models? Who owns the outputs of these models? And the intellectual property regulations around these models, like how can these models be licensed, as well as I think the ethical questions about what happens if these models are used to generate deep misinformation or deep fakes of different political personalities. There are so many complicated questions in this whole world. But I think that that's a feature, right? I think that we wouldn't be having the way to think about this, and I always tell my students this, is don't be discouraged by this negative, the negative press around generative AI. The fact that we're having these conversations means that this technology is interesting enough to work, right? We wouldn't have these conversations if it was useless, right? I think we're only having this conversation because people see both the utility and the drawbacks. And having a balanced discussion about the utility, where this technology is, what the technology is, and what it isn't, is an important part of understanding how do we as a society and as a broader computing community reason about the drawbacks as well.
That's helpful. And so let me give you a question on the other side of the balance, as it were. I asked you about some of the challenges on the negative side. What do you see as some of the exciting or the emerging trends or development that you're really looking forward to?
I again lean back on this theme of it changes the human computer interface. And I am just excited to see how a new generation of kids, the same way we saw a generation of kids raised with social media, we saw the pros and the cons, we're going to see a new generation of kids raised with ubiquitous AI and raised with technology that they can communicate with, raised with technology that they can talk to. And I think we're going to see an exciting new world of democratized technology where people can work with computers that traditionally maybe have been excluded by the computing community. On the other hand, we will see negatives the same way we see with social media. And I think that to me is going to be exciting. It's going to be, I think that a lot of the promises of democratizing computing and making it applicable to a broader community and a broader world, making these power tools that we've been designing in the computer science community applicable to everyone, is sort of coming to fruition. But there are a lot of storm clouds on that horizon as well. So I think that it's a great way to think about this, right? We see all of these opportunities, but there are real problems that we need to reckon with as people developing this technology.
So to close out this segment, let me ask you to tell us a little bit about your personal journey with generative AI, really, and how you've seen it evolve so far, and how you view the potential for the future.
Absolutely. So I am a data person born and bred. Like I love everything. I love everything about data. I have worked on projects in AI ranging from digital archaeology to medicine to robotics. I've spent my entire career thinking about how do we extract insights from data. And it is amazing to me that generative AI works. I always find it still like, I still sometimes think I'm dreaming when I'm working with some of these applications because it's so weird as a person who spent their entire life programming to suddenly talk to a piece of code that you've written, right? So I think that there's one part of me that is kind of incredulous that this actually works, right? And incredulous that the underlying technology does what it does, right? I think that my personal journey is that I am always curious about this technology from day one. From the first day that ChatGPT was released, I've been playing around with this. I've been trying different things, seeing what happens, trying to train my own models, see what happens. And I think that that's how I've been learning about this. And it's been less from some taking out a pen and paper and writing out some math equations, and it's been more like, let's play around with this. And it's kind of amazing to me where this technology has come, because when I started in this field, I would not have guessed we'd be having this type of a conversation today.
So that's really interesting. And that's probably really good advice for some of our students who want to get into this, which is to get in, try it, play with it, experiment.
Yeah, and that's the best way to understand capabilities, right? Because understanding theory without understanding the practical capabilities is not going to help us reconcile with these very real problems that are there today. Because the problems that we're talking about, 20 years ago, when people used to talk about AI safety, it was a philosophical conversation. I remember at a conference that I was at, somebody was talking about AI safety, and a faculty member stood up in the audience and saying, that's like talking about terraforming Mars, right? And it was, I think that those types of conversations have now become very, very real. And I think that the first step is understanding capabilities, understanding what kind of practical capabilities do these tools actually have today.
That's great. And I'm really glad that you mentioned data, because I think data is going to be a common theme in several of the modules of this generative AI series.
Absolutely.
So Sanjay, thank you so much for joining me today for this introduction to generative AI. I really appreciate you making the time. And thank you to all of you for joining us. I hope you'll come back and join us for more of the segments. Thank you. Welcome to the University of Chicago video series on generative AI. I'm Kevin Boyd, the Chief Information Officer at the university, and I'm very pleased to welcome to our program today, Rebecca Willett.
Thank you. It's a real pleasure to be here, Kevin. Thanks for inviting me.
Thanks for joining us. So Rebecca is a professor of statistics and computer science at the University of Chicago, and today we're going to talk a little bit about the fundamentals of AI and machine learning. So Becca, let me ask you, could you give us a little bit of an overview of artificial intelligence and machine learning, and maybe highlight for me, how is it really significant in today's tech landscape?
Yeah, that's a great question. I think we're seeing some huge changes right now. Some of them are very visible. I think many people have already played around with ChatGPT for fun, or even for, editing documents that they're writing, and have been amazed at some of its capabilities. And when we search for things like images on Google, and it can easily identify exactly the type of image we're searching for, we can attribute a lot of that success to AI technologies as well. But those are really just scratching the surface. We're seeing people use AI to help guide autonomous vehicles or self-driving cars. We're seeing AI being used for scientific discovery. So AlphaFold is an example of where people used AI to figure out how, proteins, these long sequences of amino acids, fold to form a configuration that's actually functional in our body. And then I think, we're exploring how AI can be used in all different kinds of contexts, in criminal justice, in business applications, in engineering, in medicine, and more. So it's got a lot of potential, and the pace of discovery is really phenomenal right now.
So as things are changing so rapidly, one of the questions I get asked often is, are there some core concepts that people should understand? Are there some basics that would help people understand what's really going on with generative AI?
Yeah. Well, so first let's just talk about AI and machine learning in general. And there, I think the key concept is that we're learning from data. And it's a lot like how a little kid learns something. When I was teaching my kids about the differences between cats and dogs, I would show them lots of picture books, and we'd look around at animals in the park or on the street. And I would also point out features like the size or the pointiness of the ears. And eventually they form kind of a mental model so that when they see a new animal, they can correctly identify it as a cat or a dog. And so with machine learning, we're doing something similar. We're presenting a machine with lots and lots of images of cats and dogs, and it is extracting features of those images, things analogous to size and ear pointiness, and figuring out how to, from those features, make a prediction about whether the animal is a cat or a dog. And that's a super simple example, but I think is sort of a core building block of how a lot of AI and machine learning works, where we're presenting it with just tons of examples and trying to use modern tools like neural networks to extract these models that lets them make good predictions or generate new examples.
So Becca, your last answer made me think a little bit about what we sometimes talk about with hallucination, where when we talk about cats and dogs, if we fed an image of a wolf, we might get an answer of dog, and that could be actually a data issue with how we train the model, right?
Absolutely right. Like if we're going to learn from data, then the data we feed in is super important. And so if I feed in 1 million pictures of cats and 1 million pictures of dogs and a single wolf, then I could imagine the computer saying, hey, if I never predict wolf, I'm still going to do pretty well most of the time. No one's going to get upset. But then that can cause real problems, right? And so we have to think very carefully about how we curate and select the data that we use to train these methods and how the methods are going to be used and how that should inform the way we form these data sets.
Interesting. Okay. So it seems like over the last couple of years, we've been speaking mostly about generative AI, or at least it seems like in the public eye, that's what we're talking about over and over again. But can you help us understand a little bit about the difference between generative AI and the discriminative AI, which seemed like the predecessor to this?
Yeah, I think of discriminative AI as being more prediction oriented. Like I feed in an image and I want the AI system to tell me what type of animal it is or what is the content in that image. Or even, in the context of medicine, does this image contain cancerous cells or does it not? Whereas generative AI, I think more of as, creating new examples. So after feeding it, billions of images of dogs, I would like it to generate a new image of a dog. So they're just serving different purposes. But it turns out that a lot of the underlying mathematics and computational tools are very similar.
So that was interesting. Let me ask a little bit more about data. So can you talk a little bit about how we use data to create actionable insights with AI?
Yeah, that's a great question. I mean, data has really been the fuel guiding this renaissance. Before, for instance, in computer vision, we would maybe try to design algorithms that would take a picture and try to decide whether it was a picture of a chair or not by having a list of rules about what constituted a chair. And it took a lot of work to build that up and a lot of human insights. And that's just completely different than what we can do today in completely data-driven models after we fed these systems examples with millions and millions of different types of chairs of all shapes and sizes and colors. And so the first teams that built some of these data sets just revolutionized the field. And when we look at what OpenAI has done with ChatGPT, a huge part of the work that they've done is building up these huge data sets that allow us to extract meaningful knowledge from data and not rely on these more rule-based systems.
I find I think sometimes people don't really understand what we mean when we talk about training. And to hear you say that, the idea that we are sharing lots of images or lots of similar data to teach a model how to recognize patterns, essentially.
No, that's exactly right. And one of the most powerful and popular tools right now are neural networks. And I think when we see these at first in the media, they seem huge and intimidating because we hear there's like billions of parameters, but the core concepts are very simple. So earlier we were talking about like taking an image of a cat or a dog and figuring out what type it is based on size and pointiness. So mathematically, I could think about just computing a weighted sum of these two features and seeing if that weighted sum is above a threshold or below a threshold. And so then I use all my training data to figure out, well, what are those weights and what should that threshold be? So now I can think about that very simple building block as being sort of a core piece, and I can daisy chain a bunch of those together to form a much larger scale and more complex system. And this is what we would call a neural network. And so a lot of the effort in this space has been about, well, what is the right way to daisy chain this, and how do we make this scalable and tractable, and how do we decide how we construct the architecture of these networks in a way that's attuned to special applications, whether it's protein or images or text.
Okay, that's great. So that's a really helpful sort of mental model of what a neural network is. Now, you are a professor of statistics and computer science. Mm-hmm. So tell me a little bit more about how statistics plays into this. How do probability and statistics influence the models?
Yeah, I think that they play a critical role. I mean, one of the big challenges that we face today is not only making a good prediction, but assessing the uncertainty associated with that prediction, right? I mean, when we're talking about identifying cats versus dogs, the stakes are pretty low. But if we're talking about predicting whether somebody should be eligible for a loan or whether somebody may or may not have cancer, the costs of mistakes are high. And we would like to be able to say, hey, I'm 90% sure that this person has no cancer, as opposed to, maybe they don't have cancer, but it could go either way. And so this is where, this is the bread and butter of the statistics world, is trying to figure out how to take data and not only make predictions, but conduct inference to really say how much certainty we have associated with different predictions.
So related to that, we sometimes talk with AI about generalization. Can you talk a little bit more about what that is?
Yes. So this is really about how well my model, after I've used all this training data to train it, how well it's going to work on new data. So I not only want to make sure that my model did a good job on all the training data where I knew the truth, I want to make sure it's going to work in the wild. And so what we see in practice a lot of times is that we've got these carefully curated data sets where we've got a training set and then a separate test set, so we can evaluate on that test set how well we're doing on new data. It can be a little bit challenging though, because sometimes those data sets are so curated that they give us an inflated sense of how well they'll work in the wild. And so in the wild, the issue is that the data has a slightly different distribution than the distribution underlying our curated data. And we need to make sure that our methods are robust to that. So for instance, if I train my autonomous vehicle to do really well in Flagstaff, Arizona, that tells me nothing about how it's going to work in Chicago. And so we need to figure out how to make sure that we can train these systems in safe, maybe dry environments, but then figure out how to exploit that and ensure that it's going to work well, generalize well in new settings.
Okay, that's great. That's very helpful. And continuing in that same vein, can you give me some examples of how machine learning and different AI algorithms are really being applied in real-world scenarios? And especially, are there some examples where it's being used in research?
Yes, it's ubiquitous. So one area where I've been doing a lot of work is in science and engineering settings. So scientists at UChicago are using AI in all different kinds of exciting ways. I have one colleague who's trying to design microbial communities that can break down plastics or that can improve gut microbiomes that are kind of out of whack. And figuring out what's the right composition of this microbial community would require just trillions of tests if it weren't for the ability of AI to help us predict which communities are good. I've got another colleague in physics who's coming up with new equations of biophysics, where he's using AI to actually learn what these equations might be from data. Another colleague in geophysics is trying to figure out how to take climate simulations, which typically have to run on supercomputers and cost millions of dollars, make them run on our laptops. And this is super important to our friends in economics who want to be able to say, how do we do economic planning in the face of climate change? This has been really hard when we can't do many computer simulations because they're so expensive. But because of AI, we just have a whole new world opened up in front of us. We also see it outside the context of science and engineering. I have a number of colleagues who are interested in societal impacts. So people are interested in establishing AI safeguards, making sure that these methods aren't being misused. And when we do this, we don't want to, have someone develop laws in isolation without understanding the technical aspects of it, because we run the very real risk that the laws will be vacuous. And we've seen this actually happen in privacy law, where the legal language corresponded to technically unenforceable and not very helpful privacy mechanisms. And this is something that we really want to avoid with AI, and people at UChicago are working actively on. We also see people using it in the context of medicine, trying to make better healthcare decisions. And even in the social sciences, we've got people thinking about how do we learn what makes a team especially functional? Can we take all of the data we have on teams, like for scientific collaborations, and figure out how to make better teams moving forward? Because we've all been on failed teams.
That is really fascinating and something I would never have thought of.
Yeah, I mean, just the amount of creativity is phenomenal. And, you know, I think creativity actually is another great point. We've got amazing work being done in the humanities. And I think, you know, when we see some of the stuff that is occurring with creative material being co-opted by AI systems, there is some fear, right, about, you know, how are creatives going to be operating in the future. And, you know, this is a real concern that UChicago scholars are thinking very seriously about. In parallel, at the same time, there's a question of whether we can use AI to fuel creativity, to introduce new modes of creative work that I think is also very exciting.
So I think that's a good place for us to wrap up. If there are students, faculty, staff who are really interested in learning more about this and diving deeper into AI and machine learning, do you have any advice for them?
Well, first of all, the internet's an awesome resource. There's a number of amazing tutorials out there. And, you know, many of my colleagues and I put our course materials and videos online. But I would also say that it's important to have a very broad view about what makes a good AI scholar or user. You know, it's not just about computer programming. That's important, but we also need to understand statistics, like we talked about, and some of the underlying mathematics. But we also need the kind of broad education that we give to our students here at UChicago. You know, as we talk about using these systems in really critical settings, like deciding who's going to get a loan or in healthcare, we have to understand some of the past things that have happened in this country that have led to potentially biased data sets or sources of unfairness, and think about how that could be reflected by or even amplified by AI methods. So without understanding that and just focusing on the technical aspects of AI development, we run the risk of exacerbating past harms. And so I think, you know, having this very broad perspective about what is necessary for making good AI tools is really going to be impactful.
That's great. Really appreciate your time today. Rebecca Willett, thank you for joining us.
My pleasure, Kevin. Thank you so much.
And thank you for joining us for this segment of our video series on generative AI. I'm Kevin Boyd, the CIO at the University of Chicago, and I hope you'll join us for more of the segments to come. Thank you. Welcome to our video series on generative AI. I'm Kevin Boyd, the CIO at the University of Chicago. I'm very pleased to welcome Professor Paula Harper from the University of Chicago Music Department and Professor Ada Palmer from the Department of History for a discussion today about generative AI in creative fields like the visual arts, music, literature, and design. So I'm really excited about this discussion today. Let's start with the basics. Can you tell us a little bit about how generative AI is currently being used across the different creative fields?
Do you want to start?
Sure. So I'm a musicologist. In music, there are a number of different tools that have spun up, like with tools for the generation of text and image, but for the creation of novel musical texts. So things like put in a prompt and receive a piece of music that has been generated by AI. So lots of tools spinning up that are used by professionals, but that can also be used by amateurs.
And speaking as a historian, but also a science fiction writer and someone with a lot of publishing contacts, it's being used for the generation of illustrations and cover art, and there's a lot of discussion of is this ethical and appropriate. With a lot of especially self-published authors are finding it much more economical to use AI-generated art than to hire an artist. And then within the field of generating texts, there are these questions of, it is now the case that you can put in, you know, write me a young adult romance novel about Ruxandra of Wallachia, the vampire raven princess, who really existed in 1480. But there's no YA romance novel about her yet, despite her being Dracula's granddaughter. So then, bloop, there it comes, and you have this vapid, unoriginal, incorrect about Hungary, but nonetheless extant text that you could then choose to submit somewhere to publish or publish yourself, making a lot of tension about how does this affect what people are generating? Is this art? Should we be looking at it? How do we use it? and that kind of thing. But it's very exciting when you just put it in and it comes out, and my undergrads come to me and like, look, the book you said doesn't exist. It exists today.
Yeah, I'm looking forward to it coming out shortly after this video publishes.
I am completely going to try that after we get done with this. Okay, so Paula, let me ask you. So can you give us an example of how generative AI is transforming traditional practices in art and design? And are there any examples where you would say that it's significantly contributed to creative outcomes?
Well, I would say in terms of traditional practices in music specifically, that a lot of the ways that these tools are being used for music right now are for maybe the less kind of vaunted and less high value musical practices in the music industry. So a lot of the tools now are great for spinning up things like library music or royalty-free music, stuff that can be used in the backgrounds of commercials or other kind of amateur audiovisual media, stuff where it's not necessarily foreground listening material. And that's sort of the reality of that kind of contemporary ecosystem, right? That music exists pervasively in this kind of background space. So generative AI is great for that. Whether that's a great state of being for music writ large, that's another question. And another one of these kind of ways that generative AI music is kind of taking the place of existing forms of music is in musical fakery. So there's a lot of production of fake music that's happening through the use of generative AI, especially around things like album leaks. The most recent Taylor Swift album leaked, and there were a bunch of AI-generated musics that were circulating as well around that, as well as the recent Kendrick Lamar and Drake rap beef. There's been a lot of conversation with generative AI happening around the peripheries of that rap beef. So yeah, the generative AI music is certainly part of these music industry spaces, just maybe not the ones that we might think of as like paradigmatic or mainstream music industry spaces.
Interesting. I guess I was introduced to some of this when the Kendrick Lamar and Drake video came out.
Like, Drake and the Weeknd.
Drake and the Weeknd. Sorry, Drake and the Weeknd. And that's a really interesting possibility that I hadn't considered with something like this.
And it really, so Heart on My Sleeve, which was a track that was not created by either Drake or The Weeknd, but in fact by a TikToker named Ghostwriter977, that's something that a lot of the conversations come back to, right? It's a real kind of flashpoint and a reference point that a lot of the AI conversations around the potentialities, both exciting and dangerous for various personnel in various creative industries.
And this is a perennial and old problem when you're living in an information revolution, because it means that things can be sped out quickly in a way that people aren't prepared for, and there aren't yet trust verification networks. So, for example, if we look at the 18th century, there were letters that Voltaire wrote back and forth to his publishers in Paris every week to say which things that had come out with the name Voltaire on them were his, and which were not, because people were putting things out saying that it was Voltaire. And you had to develop networks of trust. And it's exactly the same problem, where when someone has celebrity and you realize the new technology, printing press in this case, means that you can rush out something under their name, then the public and publishers and authors need to develop new methods for verification and figuring out what really is or really isn't, and thinking about why you care what really is and really isn't, and what the value of that authenticity is. It's exactly the same problem.
We had that in the Renaissance music as well, right? The printing press
claimed something is just going to play when Josquin has been dead for decades.
Exactly. So old story, new chapter.
Very interesting. Okay, so let's talk about creativity and originality in the context of AI and machine learning. Is it possible for AI to be truly creative? Is it merely mimicking human creativity? Is it just being derivative?
So, two facets of that. One, a huge portion of human creativity is being derivative, because you are taking a piece of music and responding to it with variation. You are taking something that is happening in the world and then creating something that responds. You are reading the Iliad and Shakespeare and Asimov and being like, I want to write something that combines the Iliad with Shakespeare and Asimov. And then you do. It's we sort of have this fixation on originality, which is a very 19th century idea that ideas should come to you when you're a philosopher sitting in a hut on a cliff. with no contact with human beings. But in fact, so much of nuance and delight is responding to other things, which humans do more nuancedly than AIs, because we can think, I'm going to focus on these things, whereas the AI has this giant mass of information from which it's drawing. One of the things I think that has been proved for a long time that AI is good at is directing humans to notice what we aren't thinking about when we try to create. So if we go back to the moments when we were trying to create computers that could play chess and that could play Go, one of the skills that those computers had was that they would always analyze every single square on the board simultaneously and make their next move based on every single one, while a human being is trying to do that. But our eyes are on one spot. We've mostly been thinking about over here. It's easy for us to not notice over there. And both players of chess and of Go learned a lot from noticing the things a computer would do that they would not, because the computer thinks slightly differently. In exactly the same way, I also compose music, and I took all the MIDIs of my compositions, fed them into an AI, asked it, compose a piece of music that I would compose. And it composed a piece of music, and it was interesting to hear what it did that yes, I would do, and what it did that no, I wouldn't do. And the next time I sit down to compose, those observations it gave me will give me ideas, increasing my creativity, the same way that chess computers and Go playing computers increased the creativity and understanding of human chess players and human Go players.
Mm-hmm. Yeah.
Interesting. Very interesting. Okay. So we touched a little bit on some of the ethical considerations when we mentioned Drake and the Weeknd. You know, so a song was released or a video was released that that wasn't theirs, even though it sounded like them. Let's talk a little bit more about some of the ethical considerations of AI-generated content in creative fields and some of the copyright and ownership.
Mm-hmm. Yeah, I don't know. Do you want to start?
I mean, here as the historian, I always zoom way out, where copyright, we just invented this a few centuries ago. It's incredibly new. Anything that hasn't been around for 1,000 years is just made up. But within that, what that means is what copyright was invented for is to incentivize creativity and to make there be an economic lifeline so that a musician, an artist, a writer has something to live on, which is a crowdsourced form of income coming from the people who are paying for it. So long as that author or artist or musician can live on what they're getting, that was one method. We don't have to use that method. We can use a different method. The problem isn't abstractly is this violating copyright. The problem is concretely people can't get paid and people can't live. A society which had universal basic income, we wouldn't even be bothering to have this conversation because everybody would be fine and producing their art anyway because their economic thriving would be supported by something else that wasn't threatened by this. Briefly to finish that, a good point that my science fiction writer friend Cory Doctorow often makes. We use the word Luddite as if it means somebody who is anti-technology, but the original actual Luddite movement, when they were attacking the machines, it wasn't that they didn't want the machines to make their jobs more efficient. It was that they were being implemented in a way that was meaning everybody was getting fired and not paid and going to have a famine if their employment was taken away from them by this innovation in technology. You need to implement the new technology in a way that doesn't cause people to go into poverty and have a famine. Policy is everything. And that's true with the AI thing. And lots of people want to make it abstractly about the principle of copyright. We're forgetting that the principle of copyright is a tool to solve another problem, not an end in itself.
Yeah, and beautifully put. I just want to reinforce the connection that you made there, right, between this conversation about creativity, which I think is so often driven by underlying anxieties about things like labor and whether it is being recognized and whether it is being compensated for, right? And so that when we're talking about a kind of absence of creativity in AI and generative AI, I think that one of the things that that's oftentimes standing in for are these anxieties about whether artists are going to be able to live off of their art, right? And imaginings of creativity as a space for the cultivation of certain kinds of skills and then the joyful performing out of those kinds of skills, right?
Yeah.
And so when we talk about creativity and can AI be creative, I think there's a fundamental no if you're using that definition, but that definition is predicated on all of these ideas about labor and compensation, and whether artists can live and joyfully produce the things that they want to do.
And we see this manifesting in just so many different areas, from musicians to
Cover
script
artists.
writers.
And it was interesting to note that the conversation about AI changed abruptly when the first AIs that could make computer programming code came out. Because before that, it was writers and artists and actors who were anxious, who are already fairly economically and politically disenfranchised populations. And then suddenly all of the computer engineers who are making this in the first place are like, oh, wait a minute, it might take away my line of income. This is a serious problem. And it became a serious problem overnight when the people making it were also threatened by it.
Which I think, too, speaks to the way that things like music and art have been used as these kind of multi-facing modalities, right? That a generative AI that is producing computer code is probably not too fun to play with, but a generative AI that can produce a music track when you put in a text-based prompt, that is fun to play with, right? So there's a really different way in which these generative AI technologies present themselves and kind of do PR work that maybe the curtains are pulled back a bit when we get into things like, oh no, this is certainly just labor.
Yeah.
As a technologist, I might say that we still find those computer code fun to work with as well.
No shade no shade to developers.
Different art. Okay. So sometimes we talk about this as either or. There's either human creativity or there's AI and machine learning, creating something. But it really isn't that simple, is it? Can we talk a little bit about how there is now collaboration between the artists and the tools, and how you see that changing some of what is coming out?
Well, here's what I'll say about that is that this is also something that has long history, that the composer George Lewis made the piece Voyager, which is for two creative, responsive improvisers, one human and one computer. He made that in 1987, right? So there's a long history of music that's being created, artists who are working with algorithms and algorithmic generation, as well as...
And even before that, right? In the 17th century, there was a fountain built outside Rome in Tivoli, which has a robotic organ that plays with water pushing it.
Oh,
from
don't even
gravity,
get me started on organs.
Right? And then people are supposed to play along beside it, and the player piano transformation, all of these things were similar revolutions. Humanity has not had the experience of living without an information revolution since 1450. We are an information revolution species. We are now native to it. This is the current information revolution. And every artist, every musician, every producer of material has been affected by the ongoing sequence of information revolutions that have been going on for 500 years.
Yeah, so you have the misfortune of being in the room with two historians who are always inclined to say, like, this is just turning up the volume, perhaps, on something that has long precedence.
I love it. So let me build on that. So where I think I'd like us to close, I'm going to ask both of you to peer into the crystal ball and talk about where you think things are going. What's the future of creative fields and AI? Where do you think we're going to be a few years from now or many years from now?
So, not predictive, but hopeful. If I could control how it would go, we would develop new and better ways to pay and sustain our creative population so that they aren't dependent upon the complications of income and sales, and I can have a steady income while producing material. And then creative people will use AI the way the Go players used the computer and the way I used the algorithm that could give me back my own music. Or a few years ago, I had some students who wanted to do a Renaissance painting in the style of something, but of something else. And they asked an AI to give them some examples so they could think about it. And there was an angel in the painting, and the AI put the wings on the angel's head instead of on the angel's body because it's an AI. And they thought that was really interesting, and they made a sort of a helmet thing that had wings on it that looked really cool in the end, which was not the computer generating it, but the computer thinking outside of a box. And that was a great thing for students to be doing in a classroom. And often when my students are doing a creative project, a student will have an idea for a video game or a video. And right now, all they can do is write the screenplay or write a description. Shortly, they might be able to have AI actually generate a mock-up of this as a part of their creative experience, right? That plus everybody getting paid enough to live would be a great combo, because we get to have our toys and we also get to have our bread and daily bread. And a compromise like that would be ideal, but the humans will always produce the best stuff, because we're going to take what the AIs are doing and what a fellow humans are doing and what Bach is doing and what computers are spitting out and combining it all together to produce something that responds to all of it.
Yeah, just want to plus one that that is my hope, if not prognostication, is that this moment, this amplification of these pre-existing trends that we've talked about, really does spur on a kind of large-scale economic change that means that creators of all sorts, professional, amateur, are like well-funded and well-supported.
Exactly, because this is an old problem. And every spring when I have students graduating and I ask what they're doing, you know, the ones who want to go be an actor or a musician or et cetera, they're going to go start bartending, and they're going to go start having their day job that will detract from their artistic output, because it's the only way to live right now. We need to solve this. If AI pushes us to have to solve it faster, but we solve it well, then thank you, AI, for getting us off our butts to solve what was already a crisis for a very long time.
That's great. All right, so let's close there. So a big thank you, Paula Harper, Ada Palmer.
This was great.
This was
great. Really enjoyed it. And thank you for joining us for this segment of our series on generative AI, talking about AI in the creative fields. I'm Kevin Boyd, the CIO at the University of Chicago, and I hope you'll join us for more of our series on generative AI. Thank you. Thank you for joining us for our series on generative AI. I'm Kevin Boyd, the CIO at the University of Chicago. I'm very pleased to have with me today Andrew Ferguson, a professor of molecular engineering at the University of Chicago. And Professor Ferguson is here today to talk to us about how generative AI can be used in science and research. So, Andy, tell me a little bit about how generative AI is already contributing to scientific research and discovery across different fields.
Yeah, so I think it's useful to think about what generative AI is compared to sort of prior AI techniques we've been using. So you can sort of classify techniques into discriminative versus generative. So a discriminative technique, or maybe the older type techniques, where if you give me an example, I can classify it and tell you, this is an image of a cat or a dog. Generative techniques allow you to go backwards and say, give me some images that have these properties that look like a cat or look like a dog. And so to draw an example from, I think, popular science, or I guess it's permeated the culture now, of course, ChatGPT, DALL-E 2, these are two famous generative models in the language space and the image space, which allow you to do things that I think we didn't even think were as possible maybe 5 or 10 years ago, that you can say, paint me a picture, with a castle and a lake and a unicorn, and it will generate this for you with sort of an incredible resolution. So we're doing something similar in science and engineering, and so I'll talk mainly in my field that I'm most familiar with, in molecular engineering, to help us design new molecules, new proteins, new materials that have particular properties. So it's really accelerating the pace of science if I can use an AI assistant to say, I would like a molecule that has properties that look like this, and it can generate one that then we can go ahead and sort of explore and test in the lab.
Okay, that's really interesting. When you talk about generating a model of a molecule, I'm assuming that there's a lot of prior data that you're using to do that. And data has been a common theme in some of our segments in this series. Can you talk to me a little bit about how data is playing a role in generative AI in science and research?
Yeah, data is absolutely the fuel that you need to train these models. And so having access to large data sets where the models can sort of learn over and produce these sort of trained models that can then be used for generating these new molecules is sort of really vital. And so what we've learned from sort of Silicon Valley, from largely language and image processing, is having access to very large so-called unsupervised data sets. has been very important. And so unsupervised you can think of as meaning that you don't necessarily have a label associated with it. And so one of the reasons that Google was really excited to host your photos for free is that it provides a great unsupervised data set. And so now image sort of models can be trained over those images. So getting supervised data is more expensive. So now you have to sort of annotate the images. You know, a human typically in the past, although that's changing now, we'd have to say this is a picture of a surfboard or a banana or a cat. And that was the way that older form models tended to like to work, connect sort of inputs to outputs, you know, see an image and learn that it is a surfboard, for example. So in science and engineering, there are particular domains where we do have access to very large unsupervised data sets. For example, the protein data bank that contains all of the structures of proteins that we know as humankind, or there are similar databases for molecules, or perhaps you know, small molecules, large molecules, polymers. And so that's where I think these models can really excel. And so now you can train a model to sort of, the way I like to think about it is learn the rules of the game from the unsupervised data. What does it mean to be a protein? What does it mean to be a polymer? And then perhaps with a little bit of more supervision down the line, you can then encourage it to say, I want a high temperature polymer, or I want a protein that does this particular function. So it's really blending those two aspects, I think, has really led us to some of the biggest successes that we've seen in recent years.
Okay, that's really interesting. So you mentioned Google Photos. So Google is using all the hundreds of photos I take of my dog to train the model to understand what dogs look like. And it sounds like you're doing some similar things in the field of molecular engineering, taking lots of data about what molecules and at a very small level can predict other things. Is that would that be like a good way to say it?
Yeah, that's right. It's sort of learning what are sort of the latent rules that underpin this class of objects, in our case, molecules or proteins, and then inverting that and sort of exploiting the rules to design new things. So there's a very large number of ways you can make a molecule or make a protein, but it's not infinite. And if you're particularly interested in a particular class of molecule or protein, that really restricts how you want to design that. For example, you know, protein that catalyzes a particular reaction in your body, maybe breaking down your food, your sugars, an amylase, for example, has got to be constructed in a certain way that it can actually engage with the sugars and break them down. And so if you would like to design an amylase with a higher activity, or maybe it has a higher temperature at which it can survive because you want to use it in some industrial process, then the model has perhaps learned enough of the rules of the game that it can give you a good estimate for what that should look like and really help focus your inquiry. So I frequently like to say that humans are really good pattern recognition machines in sort of low dimensions. You know, our visual system has evolved for 3 dimensions, 2 dimensions, but in high dimensions we don't do so great. And this is where machines can really learn these latent rules that live in these very complicated high dimensional spaces that's very hard for us to sort of parse just by looking at the data ourselves.
So continuing on that, your field obviously is molecular engineering. What are some things that you see generative AI enabling or making possible that might not have been possible otherwise?
So I think it's really massively accelerated some of the aspects of the way that we do science. So to give an example, some of the work I'm involved in is so-called directed evolution. So this is Nobel Prize winning work. Francis Arnold from Caltech was one of the pioneers. And the idea is quite simple, that you have a protein that nature has designed, it's evolved by natural selection, that maybe does a job, and you would like to then change the properties somewhat. So, you know, maybe you have a protease that digests proteins, and you would like to use that in your biological process, in your bioreactor, to operate at high temperatures and pressures. So nature doesn't typically care to operate at high temperatures and pressures, so maybe there's not a protease that exists in the natural world that does that. But the idea is maybe by starting with what nature has designed, you can make small modifications and improve it. So the idea is that directed evolution makes some random mutations to that protein. You make so-called daughter proteins, and then you then test them and figure out which mutations were good and which mutations were bad. And then you can sort of recycle around this loop. So what some of these AI generative models have enabled us to do is sort of learn where one should actually put the mutations. And so now, instead of searching blindly and locally, you can actually make big changes and make the right changes. So the way I like to think about it is you get many more shots on goal. And so you're sort of pushing in the right direction. And this is massively accelerating this process. And so now it's called machine learning guided directed evolution. And it allows you to sort of engineer proteins at a speed and a pace that was unthinkable, perhaps just even 5 or 10 years ago. And the really interesting thing that I like is that the models we're using to do this are so-called protein language models. And so instead of being trained over human language, so all of Wikipedia, you train these language models over the language of proteins, and they figure out the language of the amino acid sequence you need to lay down to give a protein a certain function. So in the same way, it's a little bit like, I'm simplifying here, it's like ChatGPT for proteins in a sense.
Oh, so that's fascinating. So normally when we talk about large language models, we have to train the model on the language, whether that's English or Spanish or Latin or whatever. So effectively, you're doing the same thing with the language of proteins.
That's right. And so it's learning sort of the language of life. And so what does it mean to be a protein, or equivalently, you could do it for DNA. And so it turns out it's very expensive to train these models. And so we're very fortunate that some big players with access to high performance compute, Microsoft, Meta, Google, are actually training these models. And in some cases, it can cost literally tens, hundreds, millions of dollars, maybe more, to train these things, but then making them open source that scientists like me, who would never be able to sort of train them myself, can then use them in all sorts of processes to help design new proteins, new biologics, new therapies.
That's really interesting. So let's keep going on some of the pattern recognition or pattern matching. Are there other ways that has implications for research, maybe more broadly than just molecular engineering?
Yeah, so we frequently think about, what are these models helping us to do? And so, summarize and parse data. Maybe the older-fashioned way we would think about that is, could we have an AI that could give me a synopsis of this scientific article, or could it distill down what the essence of this this collection of papers are? And that's certainly part of it. But I think it's sort of learning these high-dimensional and sort of what we frequently call sort of many-body correlations, the idea there's many parts moving together, interacting with one another, that we as humans find difficult to understand. If the models can pull out those patterns, then we can use them to do very useful things. So a couple of other examples are, there's something called retrosynthetic planning, and so it's a fancy way of saying, I would like to make this particular molecule, can you tell me how I should put together the building blocks and the chemical reactions to actually make it? And so AI, ML models are helping us to do that, and so they've sort of learned the patterns of the right chemical reactions with the right sort of yields and selectivities to sort of give you a high chance of making this product. Or another place that we've used it is in designing something called immunomodulators, and so this is in collaboration with some of my immuno colleagues in the Pritzker School of Molecular Engineering. And the idea is, can we improve vaccination outcomes by modulating the immune systems? This is why it's an immunomodulator. And so these are small molecules that can change how the immune system behaves to a vaccine. So maybe you would like, instead of getting a bad reaction to the flu vaccine, sometimes you have some lethargy, or perhaps you have a inflammatory reaction. Can we sort of mitigate those undesirable pathways and also boost the desirable pathways, produce sort of the immune response that you want to help sort of counter the bad bugs that you're vaccinating against?
Well, that's exciting, and I think that's something that hits home for all of us, having come out of the recent COVID pandemic. The idea that we might be able to use some of the AI tools to more quickly develop a targeted vaccine in the future. That's really pretty exciting. Okay, let's keep going on the sort of the predictive. Are there other ways that you think predictive modeling is going to be really helpful for research?
So I think, one of the really exciting, but I think difficult things that we're facing as a community is sort of a little bit of an incompatibility with perhaps the older fashioned way of doing science and the newer way of using sort of AI tools, in that many of the AI tools that we're working with are extremely flexible. It's really their sort of massive power, if you like, is being able to learn using a very similar architecture for your model. You can learn over photos or language or all sorts of things. That you have to tweak them, of course, a little bit, but they're very flexible in that regard. And so that somehow stands contradictory to maybe the ways that we're more used to thinking about doing science, that we have very hard constraints, by which I mean things like energy has to be conserved, or thinking back to your high school physics classes, angular momentum, all these sort of very strong physical laws. And so it turns out it's actually quite hard to make those things play together, these sort of hard constraints with these very flexible neural networks, these generative models that we're designing. But I think the field believes, of course, it's absolutely valuable to place these important constraints that we know the physical world operates by and educate the models about them. So this is known as physics-aware AI, or PAI. And so this is really still a frontier area, how we can bake in all of these important laws, we call them, the fancy name is inductive biases, into the model without compromising the model's capability of having, the fantastic accuracy or predictions that it already has. So we're hoping to sort of boost it by placing those two things together.
Okay, so that's interesting. And as we think about how we can improve the models and train them to make them better, I want to ask you about, what do you see as some of the challenges with AI in research? Like we've been so far speaking about some of the very positive aspects, but I assume that there are elements of AI in science and research that might not be so positive.
Yeah, absolutely. So I think maybe I'll answer first on a more technical level. So one is interpretability, and so these models are able to make fantastic predictions, but we don't always know why. And so you would like to sort of understand, why is it doing that? And so maybe again, a sort of an example that's quite popular would be sort of AlphaGo. And so this was the Go playing machine designed by DeepMind, and it would make moves that Go professionals would not understand why it's doing that. And so by picking that apart, perhaps you can learn what the machine has learned. And so there's a famous sort of Eugene Wigner quote that it's nice that the computer knows, but I would also like to know. And it's not always easy to do that. And so sometimes the highest performing models are in some cases the most inscrutable. It's very difficult to understand. And sacrificing to lower performance models gives you more interpretability, but then you sacrifice the performance. And so where do you land on that? And can we have our cake and eat it? So can we do both things? So interpretability or explainable AI, XAI is the name that goes by, is something a lot of people are very, very interested in. And part of that is also making sure you're getting the right answer for the right reasons. And so how can you trust what the AI is predicting if it can't give a justification for that? So in some cases, maybe this doesn't matter very much in the lab, that you ask it to design 1,000 molecules, you test them all, some are not good, some are, that's okay. But in other cases, maybe it's more important. And so if you're actually making medical decisions or healthcare decisions, you really want to be very careful that the machine is making a prediction and it can back it up and you have some justification, that it's not somehow extrapolating beyond its training data or it's hallucinating a result that you cannot trust and does not turn out to be correct. So I see that as a big challenge. Another aspect is bias, and so a lot of our models have bias, and so the bias comes from the training data. And so despite the best efforts to try and curate things, there are biases. And so in the in the training data we put together for molecules or the immune system or proteins, there's definitely biases just based on where scientific inquiry has led us in the past, and those are overrepresented. And so that can also lead to issues. And so perhaps one wants to think about how one can remove bias or understand the bias. And then be careful about sort of how to treat that.
Okay, that is certainly something to think about. Now, to wrap things up, I'm going to ask you to peer into the crystal ball a little bit. Talk a little bit about the future of generative AI in scientific research. What do you think the next 5 years are going to look like with AI in research?
Yeah, so one thing I've learned, it's very dangerous to make predictions. The field moves incredibly fast, and so there's literally new papers every day, and so it's very hard to keep up with where things are going, much less to predict what new exciting directions it will go in. I think one thing we've learned is a lot of the work that's going on in Silicon Valley to do with language models, image processing, can be very profitably adapted to scientific research. And most profitably, I think, by combining it with the domain knowledge that we have as scientists. And so you can understand how to combine aspects of how one treats a molecule, how one designs a molecule, what the constraints are, with some of these very high-powered techniques that are coming out of sort of Silicon Valley. And so things most recently, it's a little bit of an alphabet soup, but DDPMs, denoising diffusion probability models, these are things like DALI 2 that are making images for you. There's something called conditional flow matching, which came out, which is very exciting about how you can use that to design new molecules or materials. And so I think combining those two things is something that will continue to be successful. I think there's a sociological aspect that people are worried, is AI going to put me out of a job? And so I don't think that's going to happen. I think that what one can say is that AI is not going to replace scientists, but perhaps scientists who use AI may replace scientists who do not. I think it's going to become just a commodity tool that we all use in our scientific inquiry in the same way as nobody uses a slide rule anymore. You use calculators or you use microcomputers, and so it's just going to become a tool in doing science. And the other direction I think is really exciting is combining generative AI with automated robotics into so-called self-driving laboratories. And so the idea is that the AI is somehow the brain that is sort of designing the molecules or the experiments that one should do, and then the automated robotics can actually execute the experiments and then recycle them to the AI, which learns in this so-called design, build, test, learn cycle. So does this alleviate a lot of sort of the busy work that one might do as a laboratory scientist, that you can actually, instead of doing the experiments one after the other yourself, you can instruct the self-driving lab to pursue this task and then go over the weekend and come back and it has the answer. So this is very exciting, but of course also now we're reducing to practice in the physical real world what the AI is designing, and so we have to be very careful that if it now has access to reagents, to chemicals, to molecules, it's not making something that could potentially be dangerous. And so putting the correct safeguards once you're taking it from the electronic world to the physical world is something we need to be very careful about.
So that's really interesting. You know, we talk about AI a lot of times acting like an assistant, particularly with language and in drafting things, but the idea that it can be doing the same thing in the lab is that's an interesting concept. That's
yeah,
really
I think it's
powerful.
exciting. It's yeah, it's how one does that safely and correctly is something that the field is working on.
Very interesting. All right. Well, Andrew Ferguson, thank you so much for joining us today. This was very interesting.
Happy to be here. Thank you, Kevin.
It's great. And thank you for joining us for this latest segment on generative AI. I'm Kevin Boyd, the CIO at the University of Chicago. Have a great day. Thank you.